And welcome back to Factoring Quadratics. Yesterday we looked at common factoring, and hopefully that all made sense to you. Today we're going to look at trinomial factoring, which is a little bit more complicated, but once you get the hang of it, it's not so bad. Let's start with a real quick review of what we've looked at. So take a minute, fill out the chart, and see if you can't determine what the pattern is for B and C when it's compared to the length and width. So when you look at these, there's no pattern going from the top down, so don't concern yourself with that. However, if you look at the relationship of B to the expanded version, so once they're multiplied together, and the value of C when they're expanded, the two terms added together gives you B, and then the two numbers multiplied together give you C. So hopefully you remember from last chapter the formatting, that dreaded formatting. Of multiplying things out. So we're going to have a look. R plus S equals -4. RS equals 3. And this is the mathematical way of saying we need two numbers that multiply to give us 3, and the same two numbers multiply, or the same two numbers add to give us -4. Now, the nice thing is once we have the answer, there's no muss, no fuss. Whatever the numbers are, we just put them into our pattern. So once again, have a look. Two numbers that add to -1, and the same two numbers multiply to -56. And the signs are going to matter. Okay, you're going to find some of these questions where the numbers work, but as soon as you look at the signs, it's not going to work. In this case, we're looking at -7, 7 and 6, sorry, +7 and -8. That's better. In this case, before we do anything else, notice there's a greatest common factor. So let's take out that 2. So it's changed our values a little bit. We need two numbers that multiply to 9, same two numbers multiply to, or add to 6. Okay, those are the same, so we're going to rewrite it out as a squared. Now, you don't need to have that r plus s and rs every time. If you can do it without it, go for it. Again, anytime you have a number with the x, in this case x cubed, have a look to see if there's a greatest common factor. In this case, 3x is the greatest common factor, negative 3x. This is where having that positive x squared comes in handy because we don't know how to factor with a negative x squared. We'll look at that next class, but even once we learn how to do it, it's still harder than a positive x squared. So two numbers that multiply to give you 35 and add to give you 12 is 7 and 5. Now, we're going to start introducing you to something called decomposition. And although you can do to all of today's work without decomposition, when we get into tomorrow's work, you're going to have no choice but to use decomposition. So we're going to try and introduce you to it today so that tomorrow, hopefully, it won't be so scary. Don't worry if you don't get it figured out today. Like I said, we're going to come back to it. So here we have two numbers. What do we get under there? Two numbers multiplied together gives you 35. Same two numbers add to give you 12. And our numbers are 7 and 5. Those of you with good memories will realize that this is the in the brackets portion from the question previously. So unlike before, where we wrote everything out as x plus 7 and x plus 5, now we're going to break it up into the pieces. So that 12x disappears and gets replaced with 7x and 5x. And we're going to do something called factor by grouping. So if you go back to yesterday's lesson again, notice that crazy, remember that weird style of common factoring? We have x plus 7 in both terms. So we're going to factor out x plus 7 from both terms. Don't you go away. There we go. What are extra terms that are left over? Form the second bracket. And you have now decomposed this trinomial. Give it a shot. No. Now, sometimes you're going to run into a weird situation where you have more than one option. And my initial thought here was that it was 12 times 3 until I realized that the numbers wouldn't work. So here's a little trick. Make yourself a factor tree. And you're looking at all the different numbers that will multiply to get you 36. Once you hit values that will give you the 13, now you can start worrying about signs. A -4 and a -9 will give me a -13, and multiply to give me a +36. Factor by grouping. It doesn't matter the order. Doesn't matter the order of the values. So here I decided to go with 4 and 9. If I decided to go other way, what ends up happening is we get the same answer, but it's reversed from what we did above. Okay, so up top it was a minus 4 times a minus 9, and at the bottom it's a minus 9 times a minus 4. So we still get the same answer. Now, sometimes we're going to get goofy little things here. Let's do this with decomposition, because once you get the hang of it, you'll be able to do it without decomposition, but for now, it's kind of a weird thing. And again, I don't know what this is off the top of my head, so I'm going to make my factor tree. I know 2 doesn't go into 85, 3 doesn't, 4 won't, 5, 5 and 17. 5 and 17 will work. Got to remember those signs. And this is where that factoring comes in handy. We know that it won't work the way it is, so 17 has to be my factor. Otherwise, I won't create my second term. As you get better at this, you will recognize the conditions with which you can factor, because a lot of you probably, 17D. A lot of you probably could have guessed that there was a D in there. But with this being the first time through, I wanted to teach you the proper way of doing it. So that's it for today. Hopefully it's not clear as mud. I'd like to think that you're able to do this. Again, you are welcome to contact me via text, via email, and we'll try and go through a few concepts. And the star questions, once again, are optional but recommended. So good luck to you all.